Today we're going to look at equivalent ratios. We've already done equivalent fractions, so I think that this lesson will be pretty straightforward and pretty simple for you. If we were going to have an equivalent ratio for something, first we need to know what the original ratio is. So looking here, how many green tiles are there compared to blue? Green to blue, we have 12 green and, oops, the pen's not letting go, and 24 blue. So our original ratio is 12 to 24. But what if we didn't look at them as individuals? Instead, we looked at them as groups. What if I drew a line here and here? Now what is the ratio of green groups to blue groups? Well, there's one green group and there's two blue groups. So same thing, 1 to 2 is the same ratio as 12 to 24. Let's make another line. Sorry, this takes me forever to do, but we'll figure it out. What if we now split them across this way? Now, how many groups of green do we have? And how many groups of blue? Well, we have 2 green groups and we have 4 blue groups. These are still showing the same ratio. That's why they're called equivalent ratios. It's just a matter of how you actually decide to look at it. So let's have a word problem. Let's talk about planting a garden. It's the time of year that some people might like to get started planting gardens. And this garden is going to have a ratio of 5 marigolds to 3 geraniums. So every time that 5 marigolds are planted, 3 geraniums are planted. So that gives us a ratio of marigolds to geraniums of 5 to 3. So let's just choose 5 marigolds so we can visualize this. 1, 2, 3, 4, 5 marigolds. So every time 5 of these are planted, 3 of these are planted. Now, I don't know what type of design they're going to make out of this, but at this point, it doesn't really matter. 5 to 3. Now, my question is this. How many geraniums would Kim plant, so these ones, for every time she gets a new set of marigolds? So when there's 5 marigolds, there are 3 geraniums and the ratio is 5 to 3. What happens when there are 10 marigolds? How many geraniums would there be? Well, if I added another 5, I'd have to add another 3. So there would be a total of 10, and then there would be 6, sorry. What is the ratio? 10 to 6. Okay, next one. If there were 15 marigolds, how many geraniums would there be? Well, if there's 15, we've multiplied the 5 times 3, so we're going to do the same thing to the 3. 3 times 3 is 9, and our ratio is now 15 to 9. All of these ratios are considered equivalent ratios because they show the same proportions. If there were 20 marigolds, you're multiplying your original 5 times 4, so you're going to multiply the 3 times 4, and you're going to have 12 geraniums. So the ratio would be 20 to 12. Let's look at a few of the questions from the textbook, and we'll go over a couple of them together. On page 326, let's look at question 4. The table shows the number of beads used to make a necklace. So this particular necklace had 30 pink beads and 35 white beads. Ginger wants to make a smaller necklace, but using the same ratio of pink to white beads. How many different necklaces could Ginger make? And how do you know? The best way to do these type of questions is to set up a table like I have set up here. And We're going to think of it very similar to equivalent fractions. And so when you have 30 pink ones and 35 white ones, and she wants an equivalent ratio, but she wants the necklace to be smaller, that should tell you that we're going to need to divide. The question is, what will we divide both of these numbers by? Think of your divisibility rules. What are both 30 and 35 divisible by? Well, they're both divisible by 5. So if we were to divide them both by 5, 30 divided by 5 is 6, and 35 divided by 5 is 7. Now, we need to come up with a few different necklaces. This one is not the only one that we could make. We can now use the ratio of 6 to 7 to come up with some new ratios. What if we multiplied 6 and 7 both by 2? 6 times 2 is 12, and 7 times 2 is 14. Notice we wouldn't have gotten these ratios, this particular ratio, if we just tried to divide the original numbers. Once you've divided it and you get to your simplest form, then you can go ahead and multiply and get some other ways of doing it. Are there any other ways you could do it with using a lesser number of beads? Sure. What if we multiplied the 6 times 3? We could get 18. And do the same thing to the other one. 7 times 3 is 21. Is there another way to do it? I think there is. What if we did 6 times 4? We would get 24. And what if we did 7 times 4? We would get 28. So the question says, how many different necklaces could she make? 1, 2, 3. She could make 4 different necklaces. How do you know? You show your work in a table. That would be an explanation of how you know. Question 5 says, in a card game, each player is dealt 5 cards. Make a table to show the number of cards dealt for each number of players from 3 to 6. Write each ratio of players to cards dealt. So we know that each person gets 5 cards. So when there's 3 players, how many cards are in the game? There are 15. And when there's 4 players, there's going to be 20 cards because we're multiplying it by the 5 cards per person. 5 people, there's going to be 25 cards. And 6 people, there's going to be 30 cards. But that's not all it asked us to do. It asked us to write each ratio of players to cards dealt. Now I've got them reversed here, so I've got to go backwards. Players needs to be first, and cards dealt needs to be second because that's the way they've asked it. Okay, so the next one, when there's 4 players, the ratio is 4 to 20. When there are 5 players, the ratio is 5 to 25, etc. So I think you can figure that out and finish that up. The final question we're going to look at together is question 6. It says, the ratio of players to soccer balls at a practice session is 5 to 2. So I've put that into the table. How many soccer balls are needed for 20 players? Well, we know that the ratio needs to be the same. So how did I get from 5 to 20? What did I do? This is very similar to our equivalent fractions. I multiplied by 4. So I need to do the same thing to find out how many soccer balls I'm going to need. I'm going to multiply by 4.